Hello everyone, I am Dr. P. Kumari, Associate Professor, Department of Mathematics in Institute of Aeronautical Engineering College. Today, I would like to discuss some of the problems on formation of partial differential equation by eliminating arbitrary constants and functions. So here I am going to discuss one problem now, that is derive a partial differential equation from, what is the function given here? 2z equal to x square by a square plus y square by b square. So here I am going to derive partial differential equation from this equation. What is that? 2z equal to x square by a square plus y square by b square. Here, by seeing this question, what we have to understand, which one we have to eliminate. Is it arbitrary function or arbitrary constants? So in the equation, what are the things available? Based on that, we have to eliminate. Here in this equation, A and B, these are the arbitrary constants. These two are available in the equation. So I need to eliminate these two from the equation to derive a partial differential equation or to form a partial differential equation. So here, observe the solution. First, what is the given equation? So, in the data, what is the given data? First, I am writing given 2z equal to x squared by a square plus y squared by b square. So, this is the equation. So, according to the procedure, first I have to calculate dou z by dou x, and second one I have to calculate dou z by dou y. After that, I have to simplify these equations to get a PDE. So here I need to do the partial differentiation with respect to x and partial differentiation with respect to y. After then I am going to simplify the equations to get the PDE. So that is the first step I am doing here, differentiating partially with respect to x and y. So first I am doing with respect to x here. So dou z equal to x square by a square plus y square by b square. Now I am doing first with respect to x. So 2 is the constant. So their derivative is dou z by dou x. I am doing with respect to x, right? So dou z by dou x. Now here 1 by a square is the constant. So derivative of 2x square is 2x. Derivative of x square is 2x. Plus here. So according to the rules, or what are the information we are having about partial differentiation? So when you are doing with respect to x and one variable, so another variable treated as constant. That means here y is constant. So if you are doing with respect to y, x is constant. So based on that rule, here 1 by a square is the constant, x square derivative is 2x. Here 1 by b square is constant and y square also constant. So derivative of according to the differentiation formulas, here d by dx of constant. So d by dx of constant equal to 0. So according to that, here I will get the 0. So finally I am getting the value here 2 into x by a square. 2 into x by a square. Here 2 into dou z by dou x. So 2 will be cancelled here. So finally I am getting the value for the 1 by a square from the equation. So 1 by a square equal to dou z by dou x into 1 by x. Here multiple when it is sending to the next side. So it is becoming as 1 by x. So 1 by a square equal to dou z by dou x into 1 by x. This is the value we can observe here. So already I know the value of dou z by dou x. So here in the previous videos I told you about the notations. So P equal to dou z by dou x and Q equal to dou z by dou y. So according to that notations, I am writing here 1 by a square equal to dou z by dou x is P. So P by x. So this is the equation I got here after doing the partial differentiation with respect to x. Now I am going to do with respect to y now. So what is the equation I am going to get? We can observe here. So up to now we completed partial differentiation with respect to x. Then we are getting the equation, that is 1 by a square equal to p by x. 1 by a square equal to p by x. Now I am going to do with respect to y. I am going to do with respect to y. So when I am doing with respect to y, x is the constants, right? So here 2 into, so dou z by dou y. So dou z by dou y equal to, here 1 by a square is the constant. When I am doing with respect to x, y, x is the constant. So that means here this value is 0. So derivative of constant value is 0. So I am replacing here, plus 1 by b square is the constant. Derivative of y square. Derivative of y square is 2y. So finally I got here 2 into dou z by dou y equal to 1 by b square into 2y. So here 2 will be cancelled. So I am writing the value of 1 by b square equal to dou z by dou y into 1 by y. So here 1 by b square equal to dou z by dou y value already I know the notations, right? I am replacing here q into 1 by y, nothing but q by y, nothing but q by y. So I got the equation 1 by b square equal to q by y. So here this is the equation. So when I am doing with respect to x, I got the equation 1 by a square equal to p by x, 1 by b square equal to q by y. These two equations I am going to simplify to form the partial differential equation. So here, after getting these equations, I am going to simplify. So here simplification we can do in any way. What are the possible ways are there to simplify the equation? That's all possible ways we can do. So there is no only one simplification or only one way. So we are having number of ways to solve the equation or to simplify the equation. You can observe here. So here I got 1 by a square equal to p by x and 1 by b square equal to q by y. So here when I am starting the problem, I told you we have to eliminate a square and b square. So in place of that, if you are replacing another values or substituting another values, what we are getting from the equations, then we can form a PDE. So that is only we are writing here, substituting these values of 1 by a square and 1 by b square in equation 1. So here what is the equation 1? Here we are taking, this is the first equation what we given in the problem. So 2z equal to x square by a square plus y square by b square. This is the equation 1. So now we are going to substitute the values of 1 by a square and 1 by b square, which we got after doing the partial differentiation with respect to x and y. So here I am writing this equation as 1 by a square into x square plus 1 by b square into y square. What is the 1 by a square value? P by x. I am substituting here p by x. P by x into x square plus 1 by b square value is q by y. So q by y into y square. So now I am simplifying this. P by x into x square means 1x will be cancelled. So px. Here also y square and y is there. So 1y will be cancelled. So here qy. So finally I got 2z equal to px plus qy. I can write this one as z equal to px plus qy by 2. So this is our required partial differential equation. So after eliminating the arbitrary constant, we can form the PDE. So what are the arbitrary constants here? A and B. So already I replaced the values 1 by a square and 1 by b square. Then here there is no arbitrary constants in the equation. So finally our partial differential equation is z equal to px plus qy by 2. This is our required partial differential equation. So we will move to one more example to get better understanding about the formation of PDE by eliminating arbitrary constants and arbitrary functions. See the next problem. So here, form a partial differential equation. Form a partial differential equation, that is PDE, partial differential equation, by eliminating A, B, C. Here, three arbitrary constants are there. In the previous problem, we have the A and B, only two arbitrary constants. In this problem, we are having three arbitrary constants, A, B, C. From what is the equation? X square by A square, Y square by B square, plus Z square by C square equal to 1. What is the given equation? X square by A square plus Y square by B square plus Z square by C square equal to 1. So here I am going to solve this as like a previous problem procedure. Then I can get the PDE. So observe here, given x square by A square plus Y square by B square plus Z square by C square equal to 1. So here, as like a previous problem, I am going to calculate dou z by dou x. That means partial differentiation of z with respect to x. After then, dou z by dou y. So partial differentiation of z with respect to y. So after that, I can eliminate the arbitrary constant by simplifying these equations. So first, I will do partial differentiation with respect to x. So that is here, according to the given equation, we can observe here. So given equation is x square by A square, Y square by B square plus Z square by C square equal to 1. So now I am doing with respect to x means 1 by A square is a constant. So when I am doing with respect to x, y is a constant, already we know this. Okay, when I am doing with respect to y, x is a constant. So I am going to follow this order. So 1 by A square is the constant. So derivative of x square. So derivative of x square is 2x. So already we know the derivative formulas, that is d by dx of x power n equal to n into x power n minus 1. n into x power n minus 1. According to that, I am writing here x square equal to 2x plus here 1 by b square. 1 by b square is the constant and y square also constant, right? When I am doing with respect to x, y is a constant. So this is 0 plus 1 by c square is a constant. I am going to do for the z square. So z square derivative is 2 into z. Z square derivative is 2 into z. For the z, so dou z by 2x. For the z, dou z by 2x. Here derivative of constant is 0. So derivative of constant is 0 here. So now I am simplifying this 1 by a square into 2x plus, so this term is 0, so 1 by c square into 2z into dou z by 2x. Already we know the notations. Dou z by 2x equal to p and dou z by dou y equal to q. So I am replacing these values here. So here this is p. So 2z into p equal to 0. So here 2 is there in the two terms. I am taking the comma. So finally I got 1 by a square into x or x by a square plus z into 1 by c square into p equal to 0. This is the equation I got here after doing the partial differentiation with respect to x. That is only given here. Okay. Next, I am doing with respect to y. So I am doing with respect to y. Partial differentiation with respect to y. So here, so 1 by a square is a constant. 1 by a square is a constant. So derivative of x is 0 because it is constant when I am doing with respect to y. X is a constant, right? So now this is 0 plus 1 by b square into 1 by b square into derivative of y square is 2y. Derivative of y square is 2y plus 1 by c square is a constant. Derivative of z square is 2z. So with respect to y, I am doing so dou z by dou y. Dou z by dou y equal to 0. Now the first term is 0. So 1 by b square into 2y plus 1 by c square into 2z. This is dou z by dou y equal to q. So this notation I am replacing here. So finally here I am taking the common 2 also. So 1 by b square into y plus 1 by c square into z into q equal to 0. So this is our equation 2 after doing the partial differentiation with respect to x. So this is the equation 1 with respect to x I am doing. So I got the equation equation number 1. So after doing with respect to y, I got the equation number 2. So I am going to simplify this one to form a PDE now. Here to replace the values, or I can do the one more simplification to eliminate the arbitrary constants. Here three arbitrary constants are there. So which one, in which way I can eliminate, we can observe here in coming part. So see. So differentiate equation 1 with respect to x. I am doing again with respect to x. You can observe here in the before equations. Here I can't write any value for the 1 by a square because one more x is there. I can't replace this value. And here also I can't replace this value 1 by b square, and one more 1 by c square is there. So that's why to overcome this problem. So I am going to do one more time partial differentiation with respect to x. So that is only I am doing now. So differentiate here partially equation 1 with respect to x again. So what is the equation I got? Equation 1. Equation 1 is 1 by 1 by 1 by a square. 1 by a square into x plus, so 1 by a square into x plus 1 by c square. 1 by c square into z into p equal to 0. This is only we are getting in the equation 1, that is 1 by a square into x plus 1 by c square into z into p equal to 0. So here I am doing partial differentiation with respect to x again for this equation. So now here with respect to x I am doing, right. So y is the constant. Y is the constant. So now again I am doing, so 1 by a square is the constant. Derivative of x is 1 plus 1 by c square into here u into v form is there. U into v form is there. I am going to apply the derivative formula d by dx of d by d of u into v equal to u v dash plus v u dash. So that means u derivative of v plus v derivative of u. So according to that I am doing here 1 by c square into u into v formula. Here u is z, v is p. So u into z into derivative of v, that means dou p by dou x plus p into dou z by dou x. So u v dash plus v u dash. V is p, right? So here this is equal to 0. So now I am simplifying this 1 by a square plus here z by c square into dou p by dou x plus p into dou z by dx also p. So p into p I can write. So this is here 1 by c square into p into p. So finally I got the equation 1 by a square plus z by c square into dou p by dou x. Dou p by dou x plus 1 by c square into p square equal to 0. So already I know p equal to dou z by dou x, right? So what about this one? Dou p by dou x means I can write dou by dou x of dou z by dou x. Dou by dou x of dou z by dou x. Nothing but this is dou square z by dou square z by dou x square. So I can write this value as a dou square z by dou x square. What is dou square z by dou x square? Already we know the notation, that is r. So I am going to replace that one. So 1 by a square plus z by c square into dou p by dou x is r. So already we know the notation. So that is p equal to dou z by dou x, q equal to dou z by dou y, and r equal to dou square z by dou x square. So according to this notation, I am replacing r here. So z into r by c square plus p square by c square equal to 0. P square by c square equal to 0. That is only equation here I. Okay. So after this simplification, I got the equation 1 by a square, p square by c square plus z by c square into r. So now what I am going to do the simplification to eliminate this is I am multiplying this equation by x. What is the equation I got now? I am going to multiply with x by x and subtracting 1 from it. So what I am going to do now? I am going to multiply this equation with x and subtracting this equation after multiplying with x. I am going to subtract from the 1. So what is that I am going to do now? You can observe here. So 1 by a square. So 1 by a square plus z by c square into r plus p square by c square. This is our equation. This equation I am going to multiply with x. Then what I am getting here? X by a square plus z into x into r by c square plus p square x by c square equal to 0. So this is our equation after multiplying with x. Now what I have to do after, then I have to subtracting equation 1 from it. So from this equation, so here x by a square plus zx r by c square plus p square x by c square. So I am going to subtract 1 equation 1. What is the equation 1? We can observe in the what is the equation 1? That is 1 by a square into x plus 1 by c square into z into p equal to 0. So I am subtracting that equation from here. So minus 1 by x by a square minus z into p by c square. So this is the equation 1, right? 1 x by a square plus z into p by c square. So here I am simplifying x by a square is cancelled. And here only c term is there. So here only c term I am taking common here, that is 1 by c square, taking common 1 by c square. So here from this I am going to take the common 1 by c square. So after taking the common 1 by c square, I got here zx into r plus p square x minus z into p. So this is equal to 0. When I am sending this c square to the RHS side, so here I got the equation zx into r plus p square x minus zp equal to 0. This is only equation I got. So finally, in this equation, there is no arbitrary constant. There is no a square, b square and c square. So here this is our final required PDE. So here our required PDE is is z x r plus x into p square minus pz equal to 0. This is our required PDE after eliminating arbitrary constant a, b, c. So this is the way to solve the given equation. So here they can give any equation. So we have to follow the procedure. First we have to do with respect to x, partial differentiation with respect to x. After then with respect to y. After then according to the problem, if x square is there, we have to do partial differentiation again one more time. Here what we followed in this problem, here we are having x square. If x is there, only one time is enough to eliminate that. But here x square is there. So here we can do the simplification one more according to the given problem. Here, that's why we done partial differentiation again with respect to x. Then I am getting the equation. Then I am doing the simplification to eliminate those arbitrary constant to get the PDE. So what are the simplification ways we are having? We can follow according to the problem. Which simplification is suitable to that problem, we will select and we will do. So here so many simplifications are there we can do, but so which one, all simplifications are right only, but we should get the PDE without ABC. I mean, we eliminate the arbitrary constants. That way you have to follow. Okay. I think you got the better clarity about the problem now. So we'll move to one more example. See here. Find. Find partial differential equation. Find partial differential equation by eliminating two arbitrary constants from given z equal to y into f of x plus x into g of y. So what is the given equation? Z equal to y into f of x plus x into g of y. So this is the given equation. We are going to eliminate two arbitrary constants. How we can say that here two arbitrary constants are there? This is f of x and g of x. So we are going to eliminate these two arbitrary constants to get the partial differential equation. So coming to the solution here, given equation is z equal to y into f of x plus x into g of y. I am treating this one as a equation 1. So according to the procedure, first I am doing partial differentiation with respect to x. So dou z by dou x equal to. So when I am doing with respect to x, we done so many problems up to now. We are having that information about the partial differentiation. So y is the constant. So y into, so f derivative is f dash. F derivative is f dash. So f dash of x. So for the x I need to do the differentiation, right? So x derivative is 1 plus here g of y is the constant because here y is the constant, right? So g of y into x derivative is 1. So what I am getting here, y into f dash of x plus g of y. So this is the equation 2 I got here. This is the equation 2 I got here after doing the partial differentiation with respect to x. Now I am doing partial differentiation with respect to y. So that is here when I am doing with respect to y, x is the constant. So f of x is constant into y derivative is 1 plus here x is the constant, so x into g derivative is g dash, so g dash of y, so y derivative is 1. So finally I got here f of x plus x into g dash of y, x into g dash of y. So this is the third equation I got here after doing the partial differential equation. Here what we are doing here again, we can differentiate with respect to x and y in the equation 2 and 3. What we are doing here. So here I am going to get the value. We can observe here dou z by dou x equal to y into f dash of x plus g of y. So now I am going to do with respect to y again. So here dou by dou y of dou z by dou x. Dou by dou y of according to this. So dou by dou y of dou z by dou x. First I am doing that means this is dou square z by dou square z by dou x dou y. So this is equal to y into, here with respect to y I am doing, right? So f dash of x is constant, y derivative is 1 plus g of y is g dash of y derivative is 1. So finally dou square z by dou x dou y equal to f dash of x plus g dash of y, f dash of x plus g dash of y. This is the value for the partial differentiation of equation 2 after doing with respect to y. So in the same way for the equation 3 also I am doing. Here dou z by dou y is there. So I am going to do with respect to x. So dou z by dou x. So here dou square z by dou x dou y equal to, here with respect to y is there, I am going to do with respect to x. So derivative of f of x. So here we can observe dou by dou x of dou z by dou y equal to. So this is dou square z by dou x dou y. Dou square z by dou x dou y. So f of x derivative is f dash of x plus here g dash of y is the constant, x derivative is 1. So finally I got here f dash of x plus g dash of y. What I got here? F dash of x plus g dash of y. So for the third equation also I got dou z dou square z by dou x value. For the second equation also I got dou square z by dou x dou y value same, that is f dash of x plus g dash of y. Here also f dash of x plus g dash of y. Same thing only I am writing here in the next step. So dou square z by dou square z by dou x dou y equal to, after doing that simplification I got dou square z by dou x dou y equal to f dash of x plus g dash of y, f dash of x plus g dash of y. Now I am doing, after getting this value I am going to do the simplification. So what is that simplification means? Equation 2 is multiplied with x. What is the equation 2? Here we can see dou z by dou x equal to dou z by dou x equal to y into f dash of x, y into f dash of x plus g of y plus g of y. This is the equation 2. And what about the equation 3? Equation 3 is dou z by dou y equal to dou z by dou y equal to x in f of x plus x into g dash of y. F of x plus x into g dash of y. This is the equation 2 and this is the equation 3. So I am going to multiply with x here, with x multiplication, x into dou z by dou x equal to x into y f dash of x plus x into g of y. What I got here? X, y into f dash of x plus x into g of y. The same way I am going to multiply equation 3 with y. So here y into dou z by dou y into dou z by dou y equal to here y into f of x plus x into y g dash of y, x into y g dash of y. So now I am going to add these two after multiplying here. Second equation is multiplied with x and the third equation is multiplied with y. Now I am going to add this equation. I am treating this one as equation 4 and equation 5. So I am going to do equation 4 plus equation 5. What is equation 4 here for the LHS part? X into dou z by dou x plus y into dou z by dou y equal to, here what is the RHS part I am going to add now. So xy into f dash of x plus x into g of y. This is about the equation 4. Equation 4. Now equation 5 I am taking. So plus y into f of x plus xy into g dash of y. So now I am taking this one as x into dou z by dou x plus y into dou z by dou y equal to, here in the two terms I am having xy common. I am taking xy into f dash of x plus g dash of y. What is that? F dash of x plus g dash of y. Plus here I am having x into g of y plus y into f dash of x. X into g of y plus y into f dash of x. So here already I know this. What is the given equation? What is the given equation? So given equation is z equal to y into f of x, y into f of x plus x into g of y. This is the given equation. This is the given equation. So here x into dou z by dou x plus y into dou z by dou y equal to xy into, here in this place I can read this one value. What is that? So already I got here f dash of x plus g dash of y equal to dou square z by 2x 2y. So in that place I am going to replace that is dou square z by dou x dou square z by dou x 2y plus here already I know that from the given equation y into f of x plus x into g of y, I can write this one as z. So finally I got this equation, that is x into dou z by dou x plus y into dou z by dou y plus z plus xy into dou square z by 2x 2y. So here in this PDE we don't have the arbitrary functions. So finally I eliminated arbitrary function. So I got the equation, that is x into dou z by dou x, y into dou z by dou y equal to z plus xy into dou square z by dou x dou y. So finally the required PDE equal to x into dou z by dou x. Finally I can write this one as x into, so x into dou z by dou x is notation x into p plus y into dou z by dou y notation is q. So that is equal to z plus xy into dou square z by dou x dou square z by dou x dou. So this is nothing but yes. So x into p plus y into q equal to z plus x y. Yes. So we are having the notations. So according to that notation, p equal to dou z by dou x and q equal to dou z by dou y. R equal to dou square z by dou x square. S equal to dou square z by dou x dou y. And T equal to dou square z by dou y square. So according to these notations, I am replacing here. So this is yes, this is small s. So finally our required PDE is x into p plus y into q equal to z plus xy into s. So this is the way to eliminate the arbitrary functions from the given equation by using this type of simplifications. So I thought that you are getting the better clarity about the eliminating arbitrary functions and arbitrary constraints from the given equation. So this is the way to solve the given equation to form a PDE by using the sum of the simplifications and partial differentiation and using the notations of the partial differential equations. So by using the partial derivatives notations, we can form the final required PDE. We can use that notation to simplify the equation also. So I am going with one more example, that is form a partial differential equation by eliminating arbitrary constants from x minus alpha whole square plus y minus b whole square equal to x z square into cot square alpha, where alpha is the parameter. So what is the given equation? X minus a whole square plus y minus b whole square equal to z square cot square alpha. So here what are the arbitrary constants we are having? A and b. So we are going to eliminate this a and b to get the partial differential equation. So we are moving to solution. Observe here, given x minus a whole square plus y minus b whole square equal to z square into cot square alpha. So now according to the procedure I am going to calculate dou z by dou x and dou z by dou y. We can observe here in the solution. First I am doing differentiating partially with respect to x and y. So first dou z by dou x equal to, so here x are 2 into x square, derivative of x square is 2x So according to that, I am writing here 2 into x minus a. And x derivative is 1 minus 0. Plus for the second term, already we know that y is the constant, so we can write this one as 0. Otherwise, if you want to the value for that, so derivative of y square is 2 into y, right? So 2 into y minus b. So derivative of y is 0 and constant is 0. So finally we are getting the 0 here for the total term. So here this is about the left side LHS part. Now for the RHS part, I am getting here z square cot square alpha is constant. So here z square derivative is 2z. So z partial differentiation is 2z by dou z by dou x. So finally I got the value 2z by dou x equal to 2 into x minus a plus 0, that is equal to cot square alpha into dou z by dou x into 2z. So according to the notations, I can write this value 2 into x minus a equal to 2 into z into dou z by dou x is p into cot square alpha. This is the equation after doing the partial differentiation with respect to x. That is only be given here. Now we are doing with respect to y. So 2z by dou y. So dou z by dou y is here. So first term is x. X is the constant, right? So if I am writing this value also 2 into x minus a, x derivative is 0 plus 2 into y minus b, y derivative is 1 minus 0 equal to cot square alpha is constant. So I am writing here derivative of z square is 2z and dou z by dou y. So now I am writing this one as first term is 0 plus 2 into y minus b equal to cot square alpha into 2z into dou z by dou y is q. Dou z by dou y is q. So here I can write this one as taking 2 common. So 2 into y minus b equal to 2 into z into q into cot square alpha. Here 2 will be cancelled. I am getting the equation that is y minus b equal to z into q cot square alpha. After doing the partial differentiation with respect to y, that is only we got in the next, that is y minus p equal to zq into cot square alpha, and here 2 will be cancelled. For the x minus a equal to zp into cot square alpha. So these two equations I got after doing the partial differentiation with respect to x and with respect to y. So now I am going to simplify these two equations. I am taking this equation as equation 2 and this one as equation 3. So I am going to simplify equation 2 and equation 3 to get the PDE. So see here, what is the equation 2? X minus a equal to zp into cot square alpha. This is the equation 2. And this is when I am doing with respect to x, that is dou z by dou x, then I got this equation. If I am doing with respect to y, so partial differentiation, that is I got y minus b equal to z into q into cot square alpha. What I got? Z into q into cot square alpha. I am treating this equation as equation 3. We can observe here x minus a equal to zp into cot square alpha, y minus b equal to zq into cot square alpha. You can observe here. So now here, what is the given equation in the problem? That given equation is x minus alpha whole square. So sorry, x minus a whole square plus y minus b whole square equal to x minus a whole square plus y minus b whole square equal to z square into cot square alpha. So z square into cot square alpha. This is the given equation. So now To eliminate these two values, I am going to simplify the second equation is I am squaring on both sides. What I am doing now, I am simplifying this one, squaring on both sides. So after squaring on both sides, what I am getting here, x minus a whole square equal to, this is z square, p square, r square alpha whole square. So that means here x minus a whole square equal to, I got here z square p square got power 4 alpha. This is the equation about the squaring on both sides for the equation 2. Now I am going to simplify equation 3. This is also squaring on both sides. I am doing squaring on both sides. So y minus p whole square. So y minus p whole square equal to z square q square cot square alpha whole square. So nothing but I got here y minus p whole square equal to z square q square cot power 4 alpha. So now I am replacing these two values in the given equation. Substitute above values above x minus a whole square and y minus p whole square, x minus a whole square and y minus p whole square values in given equation. It is equation 1. So here x minus a whole square is z square plus 2 square into p square cot square 4 alpha plus y minus p whole square value is z square q square cot power 4 alpha equal to here z square cot square alpha. So here I am take the common z square and here I can write cot power 4 alpha as cot square alpha. So I am taking common z square cot square alpha. Here I will get p square cot square alpha plus q square cot square alpha equal to z square into cot square alpha. So here z square will be cancelled, cot square alpha will be cancelled. So finally I got here p square cot square alpha plus q square cot square alpha equal to 1. So here I can simplify this, otherwise I can keep it as it is also. If I am simplifying, I'll get here p square plus q square equal to 1 by cot square alpha. So like this I can simplify. Otherwise, just we are going to eliminate only arbitrary constants here. In this equation, we don't have the arbitrary constant, means we can keep it as it is. No need to simplify more. So what they are asking in the problem, they are asking to eliminate the arbitrary constant and derive the PDE. So we are getting the PDE here. No need to give more simplification. If you are writing next one also okay. Otherwise, if you are stopped here also okay. So this is the final partial differential equation after doing the simplification to eliminate the arbitrary constant in this problem. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.